and thank you for joining me on today's tutorial of 1.1 Foundations of Algebra. Today we are going to begin by discussing the foundations of algebra. It is so important to know where everything in algebra comes from, to have that base foundation, to know your vocabulary, to know your notation, to know the symbols and what they mean. So today we'll be going through that vocabulary, that notation, and those symbols to build that foundation. What is algebra? How do we use it, and how can it represent real-world patterns? A foundation in a building is so important so that building doesn't crash and fall, so that it can uphold anything that comes its way. For example, an earthquake. A building with the proper foundation will not fall when an earthquake comes because it has that sturdy base. Buildings that do not have that base fall when they do not have that stable foundation. And so that is why it's so important to have a foundation, just like in math. Those of you that have the foundation, the proper foundation, will be able to build on your learning and understanding and knowledge just like different floors of a building. You have that base foundation, and so every time you build it higher and higher, it stays sturdy. Those of you that do not have that basic foundation, you're going to fall and crumble when you don't understand something because you don't have that background information. You don't have that foundation in place. And when an earthquake happens, for example, learning something difficult or challenging, you won't fall and break either because you have that stable foundation. So let's continue. Our main focus on today's activity is that expressions and equations represent patterns in the real world. This is why we use expressions and equations. They're not just some numbers that your teachers like to torture you with that have no meaning. No, they happen naturally in the real world, and patterns happen in the real world. In order for us to put sense and make sense of these patterns and be able to make predictions, we need some type of representation. And that is where expressions and equations come in. Let me make that bigger. Expressions and equations come in. They put concrete meaning, and they make a nice written rule or pattern visual for us to be able to understand what's happening and make predictions in the future. So we're going to start today with vocabulary, and we're going to look at what is a variable. A variable is a letter. Oh, that's huge. Let's go to smaller. A letter that represents any number. So a variable represents any number. It can be a changing number because the word vary means changing. Varies means change. It can represent a changing number, and it can represent an unknown quantity. If I said I have X amount of dollars in my pocket right now, that could be anywhere from $0 to $1 million, even though $1 million probably would not fit in my pocket, but that'd be great if it was there. But X can represent any unknown number or value. It also can represent one that can change. Okay, well, right now it could be $10 in my pocket, but by 5 o'clock today it could be $3. And then by 7 o'clock it could be $11. So it could be a changing quantity. Another word that we need to look at is patterns. Patterns are something that repeats over and over again. It's a rule or a sequence, and I also like to call it a template. A template in Microsoft Word, in Keynote, in Google Slides, in PowerPoint, whatever you use, has a preset template so that you can just fill in your information or your pictures and then have it look a certain way. That's what a pattern is. A pattern is a template that you can follow. If it says turn right 3 times and jump 4 times, that's the pattern you will continue to follow so that every single time it comes out the exact same way. A relationship, whether it's among people or numbers or whatever, means having something in common and having a common connection. Having a connection, something in common. And this is important because when relationships start to happen, that's when we start to find patterns. That's when we start to make those connections in our head. And math is a lot about relationships. And if we can recognize those relationships and put words to those relationships, it's going to help us understand math even better and finalize that foundation even more. Let's look at the word expression. An expression in English, and let me turn off my, there we go. An expression in English is a phrase or a saying or a sentence, and it's very similar in math. In math, an expression is a number sentence. And I like to call it one-sided. What I mean by that is that there's no equal sign. So for example, if I had 3x plus 2 equals 17, this is what we call an equation, and why I say it's two-sided, because you can see there's two sides because you have your equal sign. An expression is without that equal sign, and it's just the one-sided. So it's just that number sentence. And what we can do with expressions is we can evaluate expressions. And what that means is we plug in a value and we follow order of operations. To simplify that expression down to one number. We simplify the expression down to one number. We evaluate. We plug in the value. We don't solve expressions, we evaluate them. And now, an expression is another type of template. But this one is more of a mathematical template. So you might notice a similarity and a relationship. And that relationship is between patterns and expressions. They are the same thing. A pattern and an expression are the same thing. But patterns are with words. For example, if I want to say we start with 520 and add 30 every month. So now this doesn't have too much meaning, but let's say we're talking about money, right? If I put $520 in my bank account and every month I add $30, this is my pattern in words. Then my pattern can actually turn into an expression. Expressions are patterns, but with numbers. That's number, that's what that means. And symbols. It's not the hashtag sign. Yes, it also means hashtag, but it means number. You'll see me use that a lot. So with numbers and symbols. So instead of using words to say start with $520 and add $30 every month, we would say 520 plus 30 every month we would say an M. But we'll further get into that a little bit later, how to build that expression. But you can see that 1 is in words and another is in numbers and symbols. So that's the relationship between patterns and expressions. They're the same thing, but one is in words and one is in numbers and symbols. And the reason that this is important is because when I can find what my pattern is in words, it can really help me build that expression without just trying to start with numbers in the first place. Let's move on to constants. When something is constant, all right, it's always the same. Never changes. Okay? It's always the same. It's constantly like that. And then when something changes, change is something that's never the same. It's always different. And another way to describe that is to say it varies. Whoa, man, there's another relationship. Varies. Where did I see that word varies before? Oh, I saw it with the word variable. That's because there is a relationship between change and variable. We'll see even more of that relationship as we continue through the notes, but you can see that a variable is always changing. It's always changing. What could be 3, it could be 4, it could be 5, and change is never the same. It's always different. It varies. You might have also said, but I noticed some other relationship between constant and change. And the relationship being that they're opposites, right? One is always the same and one is never the same. And that's a good relationship to notice because they are two very different things, two very different values and words. So let's keep that in mind. We're going to now translate this to some real world examples, all right? So you are going to be able to identify these vocabulary words within a real world context. So let's begin. A truck rental company, for example, a moving truck company, charges a base fee of $35 just to rent the truck. So when you want the keys, you have to pay $35 no matter what, whether you are renting the truck for 1 hour or 1 month. You're paying $35 to get the keys in your hand. And then they charge you $2.50 for every mile that you drive after that. So let's picture this one more time. You're moving and you want to rent a truck. You go to rent the truck and they say, okay, you have to pay $35 up front just for the truck, no matter what. It's like an insurance fee. And then for every mile that you drive, you will be paying $2.50. So you start with paying that $35 when you're first there. And then for every mile, you pay $2.50 more. So if I go 1 mile, I pay $2.50. If I go 2 miles, that's another $2.50, but in total, that's $5. If I go 3 miles, that's another $2.50, but in total, that's $7.50. All right? For your total price at the end of however many miles plus that $35. So hopefully you can visualize this situation, especially with my beautiful drawing. We're going to start by looking at what do we think the constant is. What is the constant in this situation? Based on here, we said the constant is something that's always the same, never changes. It's going to happen regardless. And in this case, it's the $35, okay? And that's because this is always, you're always going to be paying $35, regardless of how much you use the truck. Even if you don't even drive the truck, you just use it to store something for an hour, you pay $35. So this is always going to be the same. And one way to look at this, here's my little hint right here, guys. In these parentheses, I'll be telling you hints to help you find them, identify the constant in the situation. It's usually your starting amount, how much you start with. So you start by paying $35. And let's highlight that so that you guys know that this is my little hint here. It's usually your starting amount. So you know anytime you go to look at a word problem, look for your starting amount, and that's probably going to be your constant. Next, let's talk about our variable. What do we think the variable is here? Now remember, the variable is going to be something that's represented with a letter. It's something that we do not know or can represent any number of things. It can be changing, okay? And the variable needs to represent a possible value. Well, we know that there's two labels. When I say labels, I'm talking about two units in this. If I read a truck rental company charges a base fee of $35, okay? And then $2.50. So dollars is a label here. And it's for every mile. Mile is another label here. So we have dollars and we have miles. Which one do we not know? Well, we don't know the total dollars, you're right, but we do know that it's going to be $35 plus $2.50 a mile. What we do not know is how many miles. So our answer is the number of miles. That's what our variable is going to be, and we need to choose a variable to represent that. Let's choose M for miles. Okay? So the way we can find that variable, it's what we don't know. What value we do not know. All right? It could represent any amount. And here's my hint to finding the variable. It's always going to be the number of something. So if you're looking in a word problem and you're looking for what's going to be your variable, you're going to look for, what am I missing the number of? And again, you're going to identify two different labels, the number of dollars and the number of miles. But the best way to identify which one is the variable is to look at, well, which one do I have zero information on? I know that it's $35 and I know that it's $2.50 per mile, but I don't know how many miles. My total price is going to depend on the number of miles. So again, remember, variable is always going to be the number of something. It's never going to be an actual physical number. It's never going to be 35 or 2.50. It's going to be the number of in some unit, miles, dollars, whatever. Okay, let's move on to the change. What is the change here? And now sometimes people will confuse the constant with the change. And there's a good reason for that. Okay, and we'll go through that in a minute. We're going to ask, what is my price changing by? How much is it changing by? And we're going to say it's changing by $2.50 per mile. Notice how I'm writing this. Okay, so first, before I move on, I'm going to say, what is my total changing by? A big thing that is a key indicator of what is my change is the word per. Okay? And that's because, ladies and gentlemen, my hint here is that it's always going to be a rate of change. Okay? You might not know what a rate is. So let's off to the side do a little side blurb what is a rate? A rate is a fraction with, this W with a slash means with, two different units of measure or labels. For example, the famous miles per hour. It's a fraction. I have miles, which is a unit of measure for distance, and hours, which is a unit of measure for time. I could have kilometers per hour. I could have dollars per hour. I could have, let's say, customers. Let me write that again. Per month. Not the most traditional units of measure or labels, but the number of customers per month. Or in this case, we're talking about the number of dollars per mile. So that is what a rate is. And your rate of change, your change, will always be written as a rate. Okay? It's always going to be written as a rate, because it's that constant rate of change. That is where some people get confused when they're looking at constants and change. Some people will say, oh, the constant is $2.50 because that's how much they pay for every mile. They're constantly paying $2.50 every mile. True, but it's changing their total. $2.50 and then $2.50 per mile and then $2.50 per mile. You're right, they're constantly paying that, but this is for 1 mile, for 2 miles, for 3 miles. Their total is changing based on that. So people sometimes call it a constant rate of change. And that's true, but that's our rate of change is different than our official constant. Does that make sense? It's that changing at that constant rate, but it's still changing. Next, we're going to look at what is the pattern in words. The pattern to explain this situation for how much money you would pay. Well, you start by paying $35. And then you add $2.50 per mile. Okay? This is always going to be in words. The reason we want to do that is because we want to, that's our hint, we want to be able to translate that to our expression, make our life a lot easier. So, what is the expression? This is with numbers and symbols. If I start with 35, I simply write 35. And I just follow what the word says. It says add, so I'm going to add $2.50. Okay, so we'll add $2.50. Now I'm going to put 2.5. I'm not going to put that 0 at the end. That's because it's a decimal. It's not necessary. If I put that 0 at the end or not, it's the same thing. Okay, and now it's per mile. Per mile, that's my rate of change, and that actually, the number of miles, is my variable. So that gives us our M right there, because that means we're going to multiply times M. $2.50 times the number of miles. When I have 2.5 right next to the M, that means multiplying. Another way we can write it is in the opposite direction. They paid $2.50 per mile plus that $35 fee. Oh, that was weird that it did that line. Plus that $35 fee. So now we can find a couple possible payments. If I want to go 30 miles, I have now written an expression to help me figure out any price for any time or any distance. So I know I pay $35 plus $2.50 per mile. Well, M represents the number of miles, and now I know how many miles I'm going to go. So it's going to be 35 plus 2.5 instead of M. I'm going to say 30. And now I'm going to do the math. I don't need any parentheses or anything because the order of operations says you multiply first. Ladies and gentlemen, right here, what this means is 2.5 times 30. That's instead of the dot. Parentheses mean multiply. All right? So, and those parentheses are necessary because if I didn't and I just plugged in that 30, that actually is 2.530. So those parentheses are necessary and that means multiplication. So if I do 2.5 times 30, that's going to give me 75. Oops. That $75 represents how much money I'm paying for my miles. But now I still have to add my $35 for the truck rental. And that gives me $110. So it would cost me $110 to do it, to rent the truck for 30 miles. Why don't you try right now? You can pause the video and try on your own for 52 miles and then 264 miles. Remember, we start with the expression $35 plus $2.50 per mile. And we're going to, instead of the M for miles, we'll plug in how many miles we're going to go. We'll multiply first the number of miles times $2.50, and then we'll add it to 35. So go ahead and pause the video and try it on your own. And then you can play the video to see if you got the same answer. I will continue. So I have 35 plus 2.5 instead of M, I plug in 52. And I do 2.5 times 52. Do it on your calculator. No need to waste your time. I get 130. So $130 represents the amount of money for miles. And then plus that original $35 is $165 total to rent the truck for 52 miles. Last but not least, we'll plug in our 264 miles, a long trip, and we'll multiply 264 times 2.5, that 250. That gives me 660 plus the $35 for a total of $695. So that is how we identify the different parts in a word problem, these different vocabulary words. And then we can build a pattern to build an expression and then find our answer for any number of miles. But let's look at what if you're not given any type of scenario? What if you're just given the numbers or the expressions? So let's break this down. Let's identify the parts of the expression. We're going to start with a term. In English, a term means a word. And that's the same thing in math. It's the words, and I put that in quotations, the words of a number sentence. Again, I'm not saying hashtag sentence, I'm saying number sign, okay? And in a sentence, the words are separated by the spaces. It's the same in math. Our terms are separated by plus or minus signs. The plus sign can represent a positive or a plus. It's the same thing. And a negative can represent a negative or a minus. Same thing. So let's look at a couple examples up here. Let's look at 3x squared plus 2y minus 18x plus 17. We'll also look at 4xy squared minus 12y squared plus 15x squared minus 13xy plus 72 minus 81y. And last but not least, we'll look at 17y plus 13m squared minus 2. All right, so let's identify how many terms there are. What we do to find the terms is we start all the way at the left, and we keep going until we run into that plus or minus sign, that positive or negative sign. So I have one term, and I stop before that sign. That sign gets connected to the number that follows, like a magnet. So it is plus 2 or positive 2. And then I keep going until I see another one and another one. So I have 1, 2, 3, 4 terms in this expression. If we look at the one underneath it, again, we start and we go until right before that negative sign. And I include that negative sign in my next one. Because when I'm looking at terms, I don't want to look at it as a positive, a plus or a minus. I want to look at it as a positive or a negative. So here I have positive 4xy squared, negative 12y squared, positive 15x squared, negative 13xy, positive 72, and negative 81y. And so here I have 6 terms. Last but not least, we'll do it again. I separate my terms, and here I have 3 terms. I have a positive 17y, a positive 13m squared, and a negative 2. Again, when we separate those terms, look at them more as positives and negatives, not plus or minus. So in our example, we can separate our 2 terms to positive 3x. If there's nothing there, it's positive. If there is something there, it's obviously going to be a negative sign or a plus sign. But if there's nothing there, it's positive. Next, we're going to talk about the variable. Remember, the variable is the letter. That's easy to identify because it is the letter in the expression. So our letter here is our x. That's our variable. Constant. The constant, remember, is that number that never changes. When I look here, I have 3x plus 5. 3x means 3 times x. So that's where we get 3x from. But if I said, okay, x equals 1, you would say 3 times 1, and that term would now equal 3. If I said x equals 2, you would say 3 times 2, and now this would be 6 plus 5. If I said x equals 3, you would say 3 times 3, and this would be 9 plus 5. If I said x was 4, you would say, okay, so now this is 12 plus 5. One more time, if I said, okay, it's 5, you would say it's 15 plus 5. Notice that this constantly is changing. But the thing that is constantly staying the same is the plus 5, plus 5, plus 5. You are always adding 5. So that is our constant. You are constantly adding 5. The constant is the term or number with no variable. That's because the variable changes. The variable changes what the term is. And so that's why it's the constant when there's no variable, because it's just always going to be plus 5. Coefficient is the number being multiplied by the variable. That's a fancy way of saying the number in front of the variable. And a coefficient is always a number. It's never a variable. So here our coefficient is 3, because 3 is being multiplied by x. 3 times x. It's the number before the variable. All right. last but not least, and actually let's quickly take a look at that before we do that. What is the coefficient of, let's do a couple examples. If I say 2x, what is the coefficient of 2x? It's the number before the variable, only the number. So it's 2. That's an easy one. What if I say negative 4y? What is the coefficient? It's only the number. That's an easy one. So here we had 2, negative 4. All right, but what if I just say the variable x? What is the coefficient of x? What's that number before? Well, some people might say it's 0 because there's nothing there. Well, remember, a number before the variable is being multiplied. 0 times x is 0, which then there'd be nothing there. I shouldn't have drawn that x. There would be nothing there. But we don't have nothing. We have an x. So what can we multiply by x to equal x? And ladies and gentlemen, that is an invisible 1. It's always an invisible 1 if nothing is there. And that's because 1 times 1 is 1. 1 times 2 is 2. 1 times 3 is 3. 1 times 4 is 4. 1 times 5 is 5. 1 times any number is itself. And so 1 times x is x. And we don't put 1x, we just put x because there's only one of them. If I had 2 x's, that would be 2 x's. 3x is 3 x's. So when I only have 1 x, we just put x. But what if I have negative x? What is the coefficient of negative x? It's the same thing, but a little bit different. This time, it is that invisible negative 1. So your coefficient is never a 0 unless nothing's there. If not, like unless no variable or anything is there. If you just have m, x, y, these are all invisible ones. You'll just never see it written that way. Last but not least, we're going to look at what is an operation. An operation is the math that's happening. Addition, subtraction, multiplication, or division. Remember, addition is the same as a positive sign. Positive sign and plus are the same. Negative sign or minus are the same. Multiplication, all right, I will be using parentheses for that, and division is usually represented by a fraction. So that's the parts of an expression when you are actually looking at a physical expression. We're going to do 2 examples really quickly. An air conditioner technician charges you $40 just to come look at your air conditioner. So let's say your air conditioner is throwing water everywhere, all right? Or it's just not turning on, or it's actually putting out hot air. Just for the technician to drive out there to look at it, you have to pay $40. Whether they stay there for 5 hours working on it, or they come just to tell you, oh, nothing's wrong with it, that happens all the time, you still have to pay $40. And then you have to pay $35 for every hour that they are there. So let's look. What is the constant? What is the number that doesn't ever change no matter what you do? And that is the $40, all right? You're always going to have to pay that $40. Like I said, even if the repairman is like, oh, look, you just have this button pressed, or oh, there was just this tissue stuck in there. I don't know. You still pay $40. Okay, our variables. Remember, the variable is what we do not know. What we do not know, and a value that we don't know that can constantly be changing. And what we can do is we can look at what two units do we have. We have number of dollars and we have number of hours. The best way to figure out what our variable is to look and ask ourselves the number of what? What don't we know? Well, we know the number of dollars. We know it's $40 and $35. What we do not know is the number of hours. Our total money is going to depend on the number of hours the repair person is working on the air conditioner. And so let's assign that the letter H. Now we want to look at our rate of change. By how much is our price changing by? And we can even look for the word per something. So $35 per hour. Remember, we write this as a fraction, okay, with those two units. We have the two units, the dollars per hour, $35 per hour. So let's identify our pattern. We start with $40 and we add $35 per hour. And now by using those words, we can find a way to write our expression. We start with $40, we put 40. We add $35, and we actually don't need that dollar symbol. Per hour, number of hours, we said was H. So times H. 40 plus 35H. This means $40 initially, plus that $35 per hour. So the number of hours, that H, times 35 plus 40. If I wanted to write it in the opposite direction, I could separate my terms and just switch them around. So what that would look like is $35 per hour, 35H, plus the $40 initial fee. So either one works. How many terms do I have in this expression? 2, positive 40 and positive 35H. My operations are addition and multiplication, 35 times H. And then my coefficient, look in our expression. What is the coefficient? The coefficient is the number being multiplied by the variable. And the number in front of the variable. That's 35. Let me give you a hint, ladies and gentlemen. Your rate of change is always made up of the coefficient over the variable. Because it's $35 per hour. $35 per my number of hours. So that is always going to be our rate of change. Let's do one more problem together. This one is looking at a full bathtub. All right, you have a bathtub that when it's full, it holds 550 gallons of water. So picture that. A bathtub full of water is 550 gallons of water full. When it is draining, it loses, so that's really important, it loses water at a rate of 2 gallons per second. So a full bathtub with 550 gallons and is losing water at a rate of 2 gallons per second. What is my constant here? What are we starting with? Remember, with constants, it's either what are you constantly having to pay or do that one time, or what is the beginning starting amount. And in this case, it's 550 gallons because you are constantly starting at 550 gallons. Our variable is going to be the number of something. The number of, we have either gallons or we have, the other label is seconds. Which one do we not know? And it's the number of seconds. I'm going to label that with the variable x. I don't know why my pencil is screwing up so much. I'm going to label that with the variable x, and that's because an S can look way too much like the letter 5, the number 5, when I do it really fast, okay? So I'm going to label that with x. My rate of change. Our rate is that fraction with the 2 units. We said our 2 units were gallons and seconds. So it's 2 gallons per second, but we need to ask, are we going up or down? And we are losing 2 gallons per second. So it's actually going to be a negative 2 gallons per second because it's going down. If I had just put 2 gallons per second, that would mean I'm increasing by 2 gallons per second. A positive 2 gallons per second means my bathtub would be filling. My pattern is we start with 550 gallons and we lose 2 gallons per second. So my expression is we start with 550 and I represent lose with subtraction and then 2 gallons per my number of seconds, x. If I wanted to rewrite that in the opposite direction, I separate my terms and all I need to do is switch them around. As long as my 550 stays positive and my 2 stays negative, that's fine. Negative 2x plus 550. So in this way, you're subtracting your 2 gallons per second first and then adding the original 550 gallons. We have 2 terms, and my operations are either subtraction and multiplication or addition and multiplication, depending on which one you wrote. Multiplication and subtraction or addition, depending on which one you put. Last but not least, what's the coefficient? When I look at my expression, I look for the number before the variable, and that is -2. Remember, like I said, it's also the numerator of your rate of change. I hope you enjoyed this lesson and you were able to build a better foundation for your algebra. Use these notes to return to. Don't just go through them once and never again. This is like your holy grail of algebra. You have all your vocabulary words, you have all the parts of an expression labeled, and 2 examples. So I hope you really enjoyed this and learned something from it. Thank you so much for going to this video and watching the tutorial. Have such an amazing